रवी मी जॉईन केलंय. हॅलो रवी जॉईन केलंय म्हटलं.
Good morning, respected dignitaries and distinguished participants of this one-week online training program. On behalf of the CAS CSAWM, we are delighted to offer a gracious welcome to all of you in this online inaugural function of training program on crop weather modeling tools for climate smart agriculture. In spite of the lockdown due to COVID-19, we appreciate your active participation in the one-week training program. The training is organized by Center for Advanced Agricultural Science and Technology on Climate Smart Agriculture and Water Management in Mahatma Phule Krishi Vidyapith Rahuri, Maharashtra, under World Bank sponsored National Agricultural Higher Education Project of Indian Council of Agricultural Research, New Delhi. One of the major objectives of CAS project is to develop the capacity among the faculties and students, not only from MPKV Rahuri, but from other agricultural universities and agriculture related organizations for the development and adoption of the precise climate smart agriculture and water management technologies. As we know, there is a need to scale up the available technologies to enable the small and marginal farmers to adopt climate smart agriculture to deal effectively with the impacts of the climate change is immense and the same to be taken up urgently. With this view, one-week online training program on crop weather modeling tools for climate smart agriculture is organized by CAST project. We got good response and received total 700 applications throughout the country. I welcome to all the participants and resource persons for this training program. We are happy to have Dr. Shirish Ravan sir, Dr. S.K. Bal sir, Dr. R.H. Patil sir, Dr. N.R. Patel, Dr. V. Geeta Lakshmi, Dr. Prabhajot Kaur, Dr. Son Banerjee, Dr. N. Subhash, Dr. K.N. Singh as a resource person. Participants will learn many things regarding crop weather modeling, then artificial intelligence and use of machine learning in crop weather modeling. Now, I would like to request our co-principal investigator and co-convener of this training program, Dr. M.G. Shinde sir, to give preamble of CAS project.
Yeah, thank you, Dr. Snell. Am I audible?
Yes, sir.
Okay. Yeah, good morning all, and welcome Dr. Shirish Ravan as the first inaugural guest speaker for this series of lectures in the training. This is regarding the CAST project, what I will be briefing about. The CAST means Center for Advanced Agricultural Science and Technology. And the center is working with the theme area, climate smart agriculture and water management. This is World Bank and ICR supported project allotted to this university, Mahatma Phule Agriculture University in Maharashtra. This is the third year of the project. And the main objectives of the project are to build or to develop the capacity of the students, faculties, farmers, entrepreneurs about the new technologies related with the climate smart agriculture and water management. All of us know that climate is changing, and the first victim of this climate change is the agriculture. And if we don't cope up with this changing climate with the help of new technologies, advanced technologies, then agriculture will be in serious condition. With this view, this project has started building capacities of students, faculties, and entrepreneurs and farmers since last 3 years. Even we have conducted so many trainings on campus, but after the lockdown, since April 2020, we immediately switched to online mode of trainings. And for the information of the speaker and all the trainings, we have conducted more than 55 trainings, online trainings till today, since the lockdown began. And we have reached more than 65,000 students, not only in Maharashtra, but also all over India and also from abroad. Then another objective of this center is to strengthen the existing MSc, MTech, and PhD programs by introducing new academic courses related to climate smart agriculture and water management, which has already been initiated and they are being conducted right now. We have also started a post-doctorate program in climate smart agriculture, and also we will be starting postgraduate diploma. Actually, it should have been started right this year, but again, because of this COVID situation, uh, 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 the existing courses or existing academic programs, they are being conducted online. And this PG diploma in climate smart agriculture, being a very practical oriented course, we thought to start it from the next year, because we cannot conduct it in online mode. But we have started conducting certificate courses through this CAST project, and there will be 3-week courses, 9-week courses, and there will be certificate courses. Then our center is also developing climate smart technologies with the help of drones, robotics, and IoT. And we adopted quite about 9 villages in Maharashtra, and where we are also deploying these technologies and building the capacity of the farmers about these new technologies. So with this brief background of the CAST, I stop here, and Dr. Snehal, you can continue. Thank you.
Thank you so much, sir. Now, I would like to request our training coordinator, our guest.
Please, other mute your speaker. Others are requested to mute.
Okay, thank you very much. Thank you, Dr. Shirish Ravan, for accepting our invitation. We are happy to have you with us. To introduce Dr. Shirish Ravan, he works for the United Nations Office for Outer Space Affairs in Vienna, Austria. In addition, his responsibilities for the program on space application, he coordinates the United Nations platform for space-based information for disaster management and emergency response, that is UN SPIDER, known as UN SPIDER globally. The UN SPIDER has offices in Vienna, Bonn, Germany, and Beijing, China, and is supported by a network of 23 regional support offices in all continents. His previous assignments include leading the UN SPIDER at Beijing office and crop monitoring program of the United Nations Office on drug and crime in Afghanistan. He has extensively worked with the countries in Asia, the Pacific, and Africa to offer technical advisory services, institutional strengthening, and outreach program for promoting applications of space-based technologies. He brings in a vast experience in use of Earth observations and geospatial technologies in the diverse application areas. He holds bachelor degree in horticulture, master's degree in environmental science, and doctorate degree in forest ecology. And he has over 40 scientific publication in various journals and publications in international journals. With this brief introduction, I would like to invite Dr. Shirish sir to express his views. Sir, please.
Good morning, all. Hope my voice is clear.
Yes, sir.
Okay. And can I ask Professor Ravi how much time I should speak, so I can manage my lecture within that time. Or is this is just the beginning inaugural and then I come back for lecture? Hello? Hello?
Actually, Professor we are having some internet connectivity problem. Sir, you
Okay.
can take your time. Before 11, you have to leave this meeting. So you can conduct your session up to 11
Okay,
o'clock.
so I
No
can
problem.
start my session now, right?
Yes, sir. Yes, sir.
Okay, good. Thank you so much. I think, okay, and sometimes background, a lot of people are keeping their microphone on and that will disturb me when I'm speaking. So it will really deviate
Yes,
me.
sir.
So
All are unmuted, sir. And no one will disturb you, sir. No problem.
okay, I see some people are unmuted and I think background noise does come and it will
No,
really disturb. So I
actually,
request everyone to
actually at
please
the
mute
start,
them.
there
And
little
if they
bit
have any questions,
sound will be there.
you can put it and coordinator the can ask me the questions so that I can respond to questions. So we
Yes,
can
sir.
have some interaction. So thank you so much. And first of all, thank you for inviting me for uh, inaugural lecture of this particular course. I think this is very important topic. Climate smart agriculture is very important, and without giving much speech before, I would like to get into my presentation where I will outline importance of this topic as well as I'll speak more onto space technology as a climate smart tool, how one can really make use of space. So this is what is scope. Also, I want to link you all the participants to a larger global frameworks that are basically accepted by all the countries in the world, and these frameworks are guidelines for basically even getting into sustainable agriculture. So I hope I can share my slides. Okay, my slides are okay, visible now. Right. So I'll be speaking more about global frameworks and space-based tools for climate smart agriculture. As I was introduced, my name is Shirish Ravan. I am based in Vienna, Austria, and I work for United Nations Office for Outer Space Affairs. I think lots of people know UNDP, UNEP, in WHO, and World Bank, and all that. But there is also office called United Nations Office for Outer Space Affairs, which is dedicated for promoting use of space technologies for better humanity. So this is a global office which is based in Vienna, and I think our mandate, we say, bringing benefits of space to humanity. And we have a lot of applications. Probably towards end I will just give glimpses of what we do so that you know us better. But I would like to straight get into the topic that is basically considered for this training program. I know that participants are from all over India, but it is organized by Agriculture University in Maharashtra, Mahatma Phule Krishi Vidyapit. I am product of the same university. I have done my bachelor in horticulture from the same university, but my college was in Pune. And I used to visit Rahuri during my sports days every year. So I have some good memories of this university campus as well. Uh, so what I'm trying to show map of Maharashtra, because I know large number of participants will be from Maharashtra, and what I'm trying to show here is the basically rainfall zones of Maharashtra. And this particular dot star, red star, this is where is my village, my native village where I belong to. I'm from this farming family. Now, purpose of showing this map is related to our topic, our discussion here, climate smart agriculture. What I'm trying to show is if you look at entire map of Maharashtra, this is the lowest rainfall zone. A lot of people think that they read the news that, oh, people from this zone, they attempt a lot of suicide, farmers suicide, because they don't have a regular rains or whatever, they are into low big debts. So suicide mainly happen here. But if you look at the hardship, you see this is where is the lowest rainfall in Maharashtra, and farmers in this region I have not heard anybody attempted suicide in my, since I know, because I'm from this village, I keep very strong connection with this. What people do here is they have adapted to the drought conditions. They got into pomegranate, bear, and grape farming, and they made fortune with their hard work because they understood how to work with this particular lowest rainfall region of Maharashtra. My Tahsil is the lowest region, rainfall point in entire Maharashtra. So my, this is the satellite image of this village. The name of my village is called Diganchi, and this is where I myself have practiced farming for many years until I really left India. Last 16 years, I am in United Nations, globally working in many countries. So, but I still have very strong connection there. Now, still, although that region adjusted for such kind of drought conditions and less water, but still we could not sustain agriculture for a long time because what happened at certain point, people started cultivating sugarcane, and sugarcane is not really the carrying capacity of the region is not really for sugarcane because the region is largely irrigated by well water. So water in the aquifers, we don't have the irrigation systems like canals. After a decade of prosperity that was brought by sugarcane cultivation, this is what is the condition of the region now. What happened is we lost all our groundwater. We cannot cultivate now sugar more, and people are not getting even drinking water regularly. So they have to wait 3 to 4 days for the water to come, and then they have to just collect water. So permanent thirst has been introduced in this particular region now. Because although people understood initially how to deal with region, but commercial, a quest for commercial crop, that led into permanent water loss. So again, after adjustment for some time, people failed into really doing smart, climate smart agriculture. They got carried away by the commercial crops, and finally now this is the fate, and this is really bad. Okay, sometimes we get very good rainfall just by chance once in a 5 or 10 years, and then you have good groundwater for certain years, but again it goes back to this particular condition. Now this gives a staunch example of why climate smart agriculture is important for sustaining agriculture and keeping good life of farmers. We are quite fortunate that Maharashtra has 80% of the, I mean, 80% of Maharashtra has the cultivated areas, which is quite a lot. I mean, I have worked in Kabul, Afghanistan. I was in charge of monitoring opium cultivation, which is an illegal crop. We call it illicit crop monitoring program. Then I was working for United Nations Office for Drugs and Crime, and Afghanistan had only 20% of agriculture. Sorry, 12% of agriculture. Of that, only 2% was irrigated. Here, Maharashtra is so lucky that we have 80% of cultivable land, but irrigated areas only 17%, means we are largely again dependent on climate and rainfall. And that's why climate smart agriculture becomes important, because larger cultivation area is still dependent on climate, rainfall, or soil moisture conditions, or drought conditions. Now, taking this example to little higher side, on the global level, what's happening, why climate smart agriculture is becoming so important now? Because there is a report from Food and Agriculture Organization, which also is an organization of the United Nations. There is a report called Transforming Food and Agriculture to Achieve SDGs. SDGs is a Sustainable Development Goals. I'm going to introduce Sustainable Development Goals in few next slides, because I think every person working in agriculture sector should know this terminology, Sustainable Development Goals. I think most of you know about it, but let me get relevance of sustainable development goals for agriculture in next few slides. But what this report is pointing out, if we just leave our state, our country, India, and then look globally, what's happening is over 815 million people are hungry, and every third person in the world is malnourished, and the food system is out of balance. And this is mainly happening because climate is one of the major reasons. So what are the problems: water scarcity, soil degradation, ecosystem stress, biodiversity loss, decreasing fish stock, and there are many things, diminishing forest cover, high level of green gas emissions. So these are the associated problem, and that has a big social and environmental cost, and the world is facing this big trouble. So with this particular slide, one can understand how big is our responsibility when we call ourselves associated with an agriculture sector. We have big responsibility of ensuring the food security of the world. And today it's not just food security, but we call it a nutritional security, which is very, very important today. And especially for India, nutritional security is very, very important, because recently there is also a report that number of stunted growth of young kids, young children, is much higher in India than before. So I think it is our responsibility basically to ensure nutritional security, and that calls for basically smart climate agriculture and sustaining agriculture. Now, I was talking about SDGs here, Sustainable Development Goals. So let us spend few minutes on understanding Sustainable Development Goals. So there's something called 2030 Agenda for Sustainable Development. Now, immediately people would think, oh, this is something driven by United Nations, or it is United Nations Sustainable Development Goals. Let me clarify that this is not United Nations. Basically, these are proposed by the member countries, and India is one of the prominent country which was participant. So what has happened, 2010 to 2015, those 10 years, we heard some term called Millennium Development Goal. So these were goals for 10 years for all the countries in the world. They were called Millennium Development Goal from 2010 to 2000. So 2005 to 2015. These were for 10 years. And there were 10 goals that countries were supposed to achieve. At the end of 2015, it was realized that Millennium Development Goals were mainly seen as driven from top to bottom, pushed to the countries, and mainly targeting the developing or poor countries. And that's why we did not see participation of all the countries in driving the Millennium Development Goals to reduce poverty or achieve better food production or all those kind of. There were not many achievements in Millennium Development Goals, and also largely achievement of these were dependent on funds received by from developed country to developing countries. Taking all these lessons into account, 2 years of consultation happened for deriving 2030 Agenda for Sustainable Development in 2015. And the outcome is Sustainable Development Goals. So what happened is, all the countries, 193 countries in the world, there was a consultation from bottom to top, from communities, districts to state to country, and likewise within Asia, then Pacific, then Africa, then Latin America, Europe. Likewise, in the region, there was consultation. And after 2 years of such consultation, finally, all the prime ministers and presidents of countries, they met in New York in United Nations headquarters, and our Prime Minister, Mr. Narendra Modi, was also there, and they approved or endorsed something called Sustainable Development Goals, which is an outcome of 2030 Agenda for Sustainable Development. This is a very interesting document. Everyone should read. We should all know what are these 17 Sustainable Development Goals for making world a better place, which is backed by 169 detailed targets. And these targets are taken by all the countries. The first time goals are supported by targets and indicators. I will explain what is that target and indicators also, and how that is related to what you are doing, and how it is also related to this particular course. I will come to that point also. But before that, we'll understand what is Sustainable Development Goal. This 17 Sustainable Development Goals at a glance. And what is more important here for agriculturists is Sustainable Development Goal number 1, which talks about no poverty or eradicating poverty before 2030. And second, the most relevant goal for agriculture is zero hunger, and this talks about the nutritional security. Then of course quality education. Right now, if we are hosting these training programs even during the COVID situation, I think we are contributing to goal 4, that is quality education. You are also contributing to sustainable development goal number 13, which is about climate action, climate mitigation and adaptation for the climate and all that, or partnership for the goal 17. So you can see agriculture has relevance to so many development goals. Out of all these 7, everyone should know by heart that these are 17 goals, and most relevant for you is the agriculture, definitely. Now, before I come to our specific agriculture sector, I would like to tell you 3 important things about sustainable development goals. It matters each and every one of you. It's not just goals driven by United Nations and taken by the governments. And definitely what has happened is governments have prepared their national development plans based on the guidance offered in these 17 sustainable development goals and 169 targets that countries should achieve. So if Niti Ayog has prepared some kind of plan or strategy for development of country, you will see a lot of inspiration for that or guidance for those plans and strategies have been taken for this 2030 agenda for sustainable development goal or in achieving the sustainable development goals here. So this is very, very universal. Universal in the sense, when we talk of zero hunger, and at home, if you don't waste food individually, then you are already contributing to somewhere to food surplus, and that will take care of zero hunger sustainable development goal. There is also goal about clean water. If you just don't throw glass of water just like that, you are already saving glass of water. So for individual also, this goal is very, very relevant, all these sustainable development goals. And also at high, as you go higher level, schools, businesses, city, countries, state, countries, for everyone. So there is a universal nature of these goals. I have a friend in steel industry in Bellary steel plant, Jindal steel plant in Karnataka, which is far away from the capital of Karnataka, Bangalore. There also he asks me how I can develop this particular campus, steel Jindal steel campus, to show that we are contributing to 17 sustainable development goals. Likewise, space agencies, likewise universities like Mahatma Phule Krishi Vidyapit should also think that how their each program, each action would contribute to each of the sustainable development goal, thereby contributing to development of your city, your university, your nation. So it is universal. Second thing is these are integrated. Integrated means you cannot achieve zero hunger without achieving improvement in the poverty situation, or you cannot improve the poverty without offering quality education, or you cannot fight with the climate change if you don't take care of the water or life below the water or life on the land. You cannot achieve overall development if there is no gender equality, if women are not well educated, and if you don't bring the women up to our standards of men education and other, you cannot achieve development. So all these goals are integrated. You cannot achieve one goal just in isolation. So we have to take care of integration of all the goals. And then transformation, what it aims at, that these goals are aiming at a very big and fundamental change in how we live on this earth. So we would like to really, through these goals which are accepted by all the countries, there is a big aim of transforming, bringing fundamental change in how we live on this earth. And for the first time, trust me, I have seen that these sustainable development goals, this particular poster, I have seen in the malls in Europe, I have seen in China on the bus stops. The front of bus stop has advertising panels. On the panel, at many places, I see sustainable development goals. So first time you can see that this transformation is really taken serious, and these sustainable development goals are promoted at all the levels by countries. And when we come to agriculture, as an agriculturist, Zero hunger is the most relevant sustainable development goal for you, which aims at ending hunger, achieving food security, and improving nutrition and promote sustainable agriculture. This is the sustainable development goal that we are dealing with as an agriculturist. Why? Because the food and agriculture sector offers key solution for development and is central to hunger and poverty eradication. This is the biggest economic sector, and we have a biggest role basically in achieving the poverty eradication. And what you need is sustainable agriculture is an urgent need, and for that we need data and information and probably tools. We are talking of smart agriculture here. So this is very important. So out of 17 sustainable development goals, this is very important sustainable development goal for us. So something more important means we should dive deep into it, right? To know little bit more about it. So I remember I told you that 17 sustainable development goals are backed up by 169 targets and also 256 indicators. So it is not simply that UN is telling that, okay, just achieve sustainable development goal 2. No, they are also giving a targets and they are also giving indicators of achievements. And these indicators need to be reported by each country on the United Nations different platforms to show what was the situation in 2015 and what happened in 2020 and then 25 and 2030. So baseline is 2015 and next 15 years we will track the progress. Now it is 2020, so already there will be reporting very soon on sustainable development goals by all the countries in the world. And so there are indicators and targets. So what it says, indicator 2.1 says by 2030 end hunger and ensure access by all people, in particular to poor people in vulnerable situation including infants, to nutrition and sufficient food all year round. This is the important target related to agriculture. There are several targets, and then you need a data to see what was the condition in 2015 and then what is in 20 and 25. Let us see something very, very important for everyone who are attending this my lecture now. Another indicator is called for sustainable development goal. Indicator 2.3 says by 2030, double the agriculture productivity and incomes of small scale food producers, in particular women, indigenous people, fishers and all that. An indicator to achieve this target is volume of production per labor unit by classes of farming. An indicator 2.3.2 is average income of small scale food producers by sex and indigenous status. So this needs, now when you read of these indicators, all of you know that we need a lot of data, a lot of statistics to prove that in 2015 what is the income of farmers, in 2020 what is the income, into by 2030 what would be the income. So you need statistics, you need economics, you need piles of data to prove that past and current data and simulations for the future, and then only one can say that okay, we are doing that. Now what India did for achieving this, now we are coming to very relevant to our training program and how we are related to sustainable development goal through this training program. Remember, this is doubling the farmer income. And you see, probably you must have heard about this. If not, you can download this particular strategy. It is called doubling farmers income. This particular strategy, it's called DFI strategy, doubling farmer income, is prepared by Niti Ayog. In 2007, this was announced. Now you can see clear-cut relations between Sustainable Development Goal 2, which is very relevant for agriculture, which advocates doubling farmer income, and Government of India has got the doubling farmer income strategy by Niti Ayog. And this particular strategy runs into 14 volumes. Each volume is 150 pages. Who formed these volumes? So these volumes are basically created by over 150 professionals coming from university researchers, agriculture universities, progressive farmers, farming organizations, and corporates involved in agriculture marketing, and all sort of experts from the world, India. They came together and they wrote these 14 volumes, and these 14 volumes are part of the doubling farmers income strategy. You can go to Niti Aayog or Agriculture Ministry's uh, website, and then you can download these 14 volumes, and each volume is 150 pages. If you can read it well, otherwise every volume has a summary of 2 or 3 pages, what this volume contains and what are the recommendations of each of the volume. So how was the situation from the past about the agriculture, then status of farming income, what should be done post production, packaging, storage, and so that loss of food is not so much, marketing related stuff. So each covers each and everything, the science, technology, farming mechanism, mechanics, knowledge, empowering farmers, risk management, risk management more about climate smart agriculture. So you can see these volumes take into account each and every aspect of farming that is needed for doubling farmers income. And smart agriculture, you will find in each of these volume, you will find a reference that how one should have minimum inputs and maximum outputs and align to the changing climatic conditions is also underlying in this. So this is very important document. These are important documents. I hope as an agriculturist, if you have not seen it, please download this. These are very easy to download and refer to these particular volumes. Then another sustainable development goal is called Sustainable Development Goal 13, climate action. And this talks about taking urgent action to combat climate change and its impact. Climate is changing, everyone knows. Everyone knows, I mean, those who were in agriculture college in Pune, we have several hostels, A, B, C, D, E, F, those kind of hostel blocks we had. And I was in that college from 85 to 89 doing my graduation, and we did not have ceiling fan. So we stayed without a fan in the room all the 4 years, and we don't really find it was very difficult. We did not miss it. But today, can someone stay in Pune without air condition in the month of summer months? It's very, very difficult. So everyone can feel. If you recall my slides about my own village, the village that had all the around the year water supply and flowing rivers, we could just go and fetch the water from our river all the time until my school days, now has permanent dried river beds. You can see that climate change is happening at all places, right from Himalayas to rising sea levels to desertification and frequent droughts. This is no more a secret. Therefore, all the countries came together and they agreed on something called Paris Agreement for Climate Change. This was adopted by 196 countries in COP21 meeting in Paris in December 2015 and came into force in 2016, November of 2016. And this is the first and very unique global framework that gives a legal binding to the countries to reduce the emissions, carbon emissions, which is main cause of climate change, by so that temperature will not rise more than 2 degrees Celsius in coming century. And therefore countries have to adjust all their industries, agriculture and everything so that earth will not get warmer. And this is very, very important and is the legal binding. Sustainable development goals is not really a legal binding yet, but climate change is a legal binding on all the countries. And by discussing the topic of climate smart agriculture, we will be making huge contribution onto sustainable development goal 13, and we have need to educate all young people on the climate change to put them on a sustainable development path as early as possible. So having said that, sustainable development goal 2 and 13 are the ones we are talking about. We have very strong relationship with other goals. And this is a wonderful chart. You will see that we are dividing these 17 sustainable development goals into 3 categories: biosphere, There here are sustainable development goals related to the life below water, life on earth, and that kind of thing, clean water. Then we have society. Biosphere is more about our, nature and ecosystems and all. Protecting here, this is the base. If we take care of all ecosystems, then we can take care of a society. And this is where we are talking about the gender equality and zero hunger and no poverty and quality education, sustainable development goals. And if we take care of society, then we can be prosperous. We can take care of economy. And this is where we can say, okay, quality jobs for people, or some other economic related infrastructure, innovation, and all other things, they are talked here. So we can categorize sustainable development goals into biosphere, society, and economy. And then we need a lot of data in order to achieve these sustainable development goals, and even to drive the actions for climate smart agriculture. And so sustainable development goals, these are 17 sustainable development goals. They also talk about data revolution for sustainable world. The first time these kind of frameworks rely heavily on the data. And when they are talking of data, they are talking of everything. Fourth industrial revolution, they are talking of artificial intelligence, crowdsource, cloud computing, satellite remote sensing, you can say the aerial, the drones, or sensors that can be fitted on this in the soil, in the field, everywhere, Internet of Things and all that. So data collected from reliable sources in timely granular data, that is needed for achieving the sustainable development goals. And if we are talking of sustainable agriculture or climate smart agriculture, we also need good information and good data to understand what is happening in each region and how we should drive. And one of the source of data, when we talk, we need a data revolution. One of the source of data is space technology, earth observation. We also call it remote sensing. And satellite remote sensing is the most common form of remote sensing today, because space is changing. I mean, decades ago there were only handful of satellites in the space. Today, every day satellites are being launched. India has so many good satellite remotes and satellites in the space now to monitor India on daily basis. You probably know there is a company called Planetium. They launched 170 small satellites. Out of that, 100 satellites were launched by India on a single rocket. So that was how India is really appreciated in space technology worldwide. Planetium asked ISRO, they took commercial contract, and ISRO launched 100 satellites in one single go, and they released in the space. Perfect launching. So now they have 169 satellites looking at Earth, and they can give images of something like 50 centimeter resolution. It means very high resolution photographs of Earth can be obtained on the daily basis. And as I go ahead, I will explain how remote sensing is now so advanced. You can estimate the rainfalls. So satellite-based rainfall monitoring. You can understand soil moisture estimations from the satellite images. So lot parameters related to climate smart agriculture you can develop, understand by the satellite images. So less and less you can need information from the field. But if you can integrate field information with satellite-based information, then you can understand conditions very, very well, and that can contribute to precision farming or climate smart agricultural techniques or sustainable agriculture. What you see here is the satellite image of a Koyna Dam in Maharashtra state. This is in Satara district, and this is very famous Koyna Dam because a lot of hydroelectric energy for Maharashtra comes from this particular dam. And satellite images often give false color, and you can see here all the red thing is a forest, intense red, because forest is much greener than agriculture and thick vegetation cover. So it's a false color. In infrared it shows red. And as you go on this side, you can see we all these catchment areas of all these dams. This is catchment, and these are command areas. In all these command areas there is agriculture. This particular red tinge are agriculture, and you can classify those things. And now you can see, when I do mapping out of it, we can understand that okay, from this dam these are all command areas. From these, you can see how much area is covered by those dams as irrigation. And this green is the forest. So you can understand. So role of Earth observation is very, very important in achieving the sustainable development goals or sustainable agriculture. And when we did a very good study with European space agencies, they have identified each of their program with sustainable development goal where it contributes. And we understood that 65 of 169 indicators of sustainable development goals can be monitored using space technology. Now, what are these space technologies then? It's not just satellite remote sensing or the Earth observation photograph that you saw. Today, in your hand, you have mobile phone. When you look at the map, when you start looking at any map, Google Map or anything, you are already using high resolution satellite images that are used for deriving those maps. When you navigate, you start GPS and you start driving, you are already using global satellite navigation systems. Only 6 countries in the world have this kind of navigation systems. So you can, India is one of these 6 countries that are having the navigation technologies, and but entire world is benefiting from this. When you are making your communication, you are using communication satellite. 2 days back, yesterday itself, I think there was big news in that ISRO launched another communication satellite. So that you are using in your phone. And when you look at the temperature or rainfall or any weather parameters, you are using weather forecasts that are partly derived from weather satellite, geostationary satellite, which are at the altitude of 36,000 kilometer. Normally, remote sensing satellites are about at 900 kilometers from the Earth, between 700 to 900 kilometers. But weather forecast satellites are mostly giving meteorological parameters. They are at 36,000 kilometers. India has satellites in all the sectors. And although you are using it on daily basis, you don't know that you are using space technology. But on every step of your life, you are using space technology today. It's part of our life. It is integrated into your every moment. But when you talk of achieving food security or zero hunger or no poverty, the challenges are much more complex than just using the mobile. You need to use all these technologies very effectively for sorting out the challenges posed in the agriculture sector. And out of that, Earth observation is very, very important for agriculture, because when you use satellite images, what you get, the data you get is a specially specially extensive mapping. So you get everything in the form of maps, and everyone knows that maps speak millions of words than a text. One page write up and one map. Map will tell you millions of things more than other data. And map is also an evidence of what happened at that particular time. So that is important. Satellite images today can monitor entire, say, India twice a day or 10 times a day today. You can just take picture of entire India, snow, agriculture, which is green, which is not green, where is moisture is less, where moisture is more. Many times you can cover India in a day. At the same time, you can go to this zoom to the level that you can even count number of cars on the road at today on any given road. That kind of satellites are available. So localized event detection can also be done. It is almost a near real time program. So what I used to do when I was in India, I worked in India, I used to monitor crop acreage and productivity. And before harvest, we used to give result for how much Rabi cotton will be produced or how much rice would be produced this year. So months before, the figures were available for authorities about understanding what is the crop condition today and what would be the tentative production. So more near real-time response can be planned. You can see something beyond human eyes. Many things as a human eye we don't understand because we have limitation of seeing only 7 colors. Vibgyor, violet, blue, green, indigo, and all those 7 colors. But satellite can see into microwaves, infrared, and what you cannot see by your eyes. Just like a doctor, the way doctor looks at if bone is broken, he takes X-ray and he sees inside that you cannot see by your eyes, but in X-ray, a crack in the bone can be very, very visible. Similar way, we can scan Earth in infrared and microwave and can understand so many things which human eye will never understand. And this gives us a lot of data that is beyond our understanding otherwise. We can cover a lot of area, dangerous sites, access to difficult sites, because we cannot go, but we have the satellite images. And most of all, since all things are in the form of map, you can calibrate it, georeference it, and one map on top of another map, on top of the another map, you can have georeference, and then you can go vertical down and understand. So irrigation condition versus current cultivation versus statistical information of the people, their income level, all these things can be analyzed and can be understood what better planning you need for agriculture. This kind of analysis can be done very well using Earth observation system. Now, this cannot be just done just for today or just for a couple of years, but you can go 50 years back. Earth observation data is available for entire world from 50 years. This kind of knowledge on Earth system, atmosphere, land, ocean, and ice coverage is available. So if you want to go back 50 years and understand what is the situation 50 years back, 40 years back, 30 years, 20 years, and now, you can also make a models for the future. And all this data is available as evidence-based information and is available for modeling, because satellite images are in digital form. They are digital numbers, and each number is indication of, its reflectance from Earth surface. So reflectance from crop, for example, when crop reflects back or emits back, that emittance is a function of biophysical property of a crop. It is about how much chlorophyll, how much anthocyanin is there, how much moisture is there, what is the crop condition, if it is affected by diseases, what is the soil moisture condition, everything is reflected there. And this is in a digital form, and you can use such information for mathematical modeling to understand condition of agriculture. So quickly, I'm now coming to climate smart space as a tool for climate smart agriculture. I have not done myself recently projects, because last 15, 16 years, I am more into promoting, space in disaster management, which is also important for agriculture, because drought and floods cause a lot of damage, and you need to know about that also. So I will try to find relevance of some of the cases to smart agriculture here. But this was one very important project I did when I was in India. I told you 16 years I'm in United Nations doing global job, but I was before that I was in India. I also worked for Maharashtra Remote Sensing Application Center, and this is where little story. I mean, our finance minister then, Mr. Jayant Patel, he came to my office and he said, "We have Maharashtra in Maharashtra. There is a Krishna Valley Development Corporation, is an irrigation system of about, I think it's about 32 or 30, 35 dams. So it has a catchment area and it has a lot of command area. And in each command area, people grow a lot of sugarcane. Per hectare, there was a water tax. I think in those days, about 18 years back, it was 3,000 per hectare per year or something like this. And he came to me and asked that we are unable to collect water tax from farmers because reporting of command sugarcane field in the command area is much, much less than what actually is. So Krishna Valley Development Corporation is unable to obtain enough revenue. How can you help to increase the revenue collection of the corporation so that we can maintain the canals and give regular salaries to the employees of the Krishna Valley Development Corporation? Because 2 3 people also attempted suicide because they did not get enough salaries on monthly basis, because there were no funds with the corporation to pay to their employees, and there were suicides from the field staff which is in the offices, not in the field. Field officers have a lot of other income, but offices, in the offices, they just do clerical work, they don't have salary. And that's the reason minister came, and then we said, okay, we will use the satellite remote sensing. So what we did is we identified all irrigation command areas in those 35 dams of Krishna Valley Corporation. Those are called Nira, Bhima, Ujni Dam, and all those kind of dams. We mapped, taking satellite images. We saw how much sugar cane is cultivated in each we overlay this sugarcane on the village maps, and we found in each village boundary how much sugarcane crop, how many acres of sugarcane crop is cultivated. So we got number of hectares in each village in the command area of that particular dam. Now we know that from one particular village how much water tax should be collected by the corporation. And then you would be surprised to know that initially in four pilot dam areas in the all villages we saw, the revenue should have been 21 crore rupees in single year, but actual collection had happened only 2 crores just in four command areas. I'm not talking of 35 command areas, how much deficit it was. So that was in that kind of inaccurate information was coming to corporation, and they were not having enough revenue. After running this program using satellite image, suddenly the reporting improved. Pressure got onto all the field staff to report all data correctly, and Krishna Valley Development Corporation boosted its revenue by hundreds of crore, and it hit the headlines in Maharashtra newspaper. There was a newspaper called Lok Satta. It was a front line news saying that a eye in the sky improved revenue of Krishna Valley Development Corporation. Now you can see that it also has relation to sustainable agriculture, because if revenue is collected well, you can plow back in maintaining the irrigation systems, thereby combating the negative effects of the climate. So this kind of information is also very, very important for climate smart agriculture. Now, this is just an interesting example, may not be related to smart climate, climate smart agriculture, but this is something I like to really show what happening outside India. What you see, the beautiful pictures here is the opium. And when opium is launched, you get a highly addictive substance called morphine. And when this morphine is purified, you get opium. Opium is the heroin is the most addictive and dangerous drug in the world. And Afghanistan is sole supplier. 94% of heroin is supplied by Afghanistan. And this is from opium farming done in Afghanistan. I was posted in Afghanistan on behalf of United Nations Office for Drugs and Crime. So I stayed among Talibans. I have flight very risky missions in the military helicopters to monitor where is the opium cultivation taking place. So what you can see here is a piece of satellite image. Opium looks like this, and wheat looks like this. And young opium looks like this. So this is opium more matured. Maybe it is like this now already in this stage. And the another one is in this, another green opium will be in this stage, and this is wheat. So I can clearly see how much opium is planted. Of course, I had to often fly helicopter to go to ground, bring the ground truth, because we cannot go on the ground too much. So we have to use those kind of resources to see it closely from the top, and then use those information for analyzing satellite images. And this we can find what is the opium acreage in entire Afghanistan. It was more of a statistical mapping also. So how much opium is cultivated in entire Afghanistan, how much is opium yield and prices, and how much we help in eradication, how much is converted into heroin, how much is trafficked, and finally, how much is the illicit gross domestic product, GDP of the country. This is very important, because if we know how much illegal GDP happened in the country, we can understand how active will be terrorism in Afghanistan. This is eradication photograph, and this is my team in Afghanistan. These people, everyone, almost most of them are graduate people. They don't look like that. But some of them have got their masters in chemistry, like this person in the beard is a MSc chemistry from Rajasthan, I think Jodhpur or somewhere once upon a time. So these are my teams which were going in the field for doing this kind of work. And every time it used to be BBC news, breaking news of telling that how much this year illicit GDP happened. And that used to plan alternative livelihood, so that people will go away from opium cultivation and do better agriculture, which is also sustainable agriculture or climate smart agriculture. So These are kind of applications we used to do. We are still doing in countries like Afghanistan. And then we come to another example. Now this is an example where there's an organization called International Water Management Institute. They do. They are part of CGIAR. CGIAR is, I think, a consortium on agriculture research. I'm sure as an agriculturist, you must be referring to a lot of work done by them. They also use a lot of space technology. And this is, I think, classic example. Why I'm taking this example? Because International Water Management Institute, which is based in Sri Lanka, has about 200 excellent scientists, team of scientists. It's based in Colombo, but it works a lot for South Asia, Africa, and also for globally. So this particular organization is also regional support office of my program called UN Spider. I will explain what is UN Spider program, but we have formal association. What they have done wonderfully is they use space technology to strengthen climate resilience policies. So important, what is the story here? We know that climate change is posing increased flood risks. More and more frequent floods and cyclones are coming and bringing the floods. Recently, you saw cyclone Amphan and cyclone Nisarga. Those who are in the west coast of Maharashtra, they know that cyclone Nisarga happens once in hundreds of years, but it is happening now. So those kind of floods are now coming. So satellite image, I told you that you can go back 50 years. So what you can do is go back in many years and see which areas are frequently flooded. So you understand which areas have more flood risks and underwater more than other area. This is what you can clearly understand at each point on the ground. And what you can do is then you can introduce flood resilient seeds to cope with climatic variability, including those historical flood frequency. What you can estimate by satellite images, not just flood frequency, but depth of the flood, duration of the flood, and other information such as soil type, soil organic matter, pH of the soil, land use, drainage conditions, and all that. Once you know this, you can understand how much area in particular state is up in the flood prone region. So one outcome came out of this program is that in Bihar state of India, this assessment estimated that approximately 100,000 plus area is flood affected, and their kharif paddy is in trouble. So if seed companies can develop 5,000 plus tons of flood resilient seed, then this will be almost a sustainable or climate smart agriculture. So this kind of risk information one can estimate using satellite images and combining with a lot of other agriculture parameters. And this can feed into the policy decisions. And these policy decisions then can, bring out the improved seed or flood resilient seeds and corn. So now you can see through all these stories that you have seen that there can be multiple applications from satellite, so that this technology can offer a lot of benefits to. So these are just few examples I told, but today sensors are so advanced that you can do a lot of other monitoring for your precision agriculture. For example, I just thought one idea. There are a lot of irrigation systems in India, but they release water just based on normal cycle, not based on the soil moisture conditions. So if you assess the soil moisture using satellite images and few ground-based sensors, one can really tell irrigation offices that, okay, this area needs this much amount of water in this after these many dates. This itself is a climate smart agriculture practice. So climate smart agriculture tools are not only for limited for growing the crop or for the farmers, but it's for considering all those systems that support the agriculture. That message you can take, and space can contribute a lot. Then I would like to quickly tell you how we are promoting this particular the thing in the world. I think I still have about 10 to 15 minutes because I have another meeting at 11 o'clock in India. It's my now 6 o'clock, 6 past 10. So it's quite early morning for me at here in Vienna. So I belong to United Nations Office for Outer Space Affairs, and our vision is to bring benefits of space to humankind. So we promote international cooperation in peaceful uses of outer space. In doing this, what we do is all the space agencies of the world, they come to Vienna on regular basis, and we run something called Committee for Peaceful Uses of Outer Space. NASA, ISRO, European Space Agency, Japanese Space, all the space agencies of the world, they come 3 times to Vienna. And we have this committee, and that takes care of how space technology benefits should reach to all humanity. For that purpose, we have several programs. And some of the programs are very relevant to you and agriculturists in India. I will come to that after next slides. So we try to promote space in sustainable development, also access to space initiatives. There are a lot of experiments one need to carry out, so that in some experiments also need microgravity testing. So we also offer how space exploration experiments can be carried out before taking it to space. We also have a program called Spider that is contributing to promoting space-based technologies in disaster management and emergency response. Also for sustainable development that covers agriculture. So we know that today space technology is very, very applicable in all the sustainable development goals. And one of the wonderful thing in terms of quality education, sustainable development goal number 4, that is called quality education, to which all agriculture universities, colleges, and research centers can contribute a lot, because quality education is not just a classroom education or university or college education. It's also education off the campus, agriculture extension education, training and visits to the farmers, or education related to organizing market systems, and also many things like currently we see all these farmers steer happening in Delhi. So why? Because also there is not enough education on why these bills came of those 14 volumes of doubling in farmers' income, what are their advocacies, how that is going to benefit farmers. So that kind of education has not gone down to everywhere. So quality education is very, very important. That is sustainable development goal 4. What we have done in terms of space is we have established regional centers for space science and technology education in all the continents. And one of the oldest center is based in India. This is called Center for Space Science Technology Education. This is in Dehradun, in the campus of Indian Institute of Remote Sensing. I'm sure some of you have already been to the campus of Indian Institute of Remote Sensing in Dehradun. I have very, very close relation with that campus because I am the first PhD student of campus of Indian Institute of Remote Sensing. In 1994, I submitted my PhD thesis almost 29 years back. And I was the first PhD candidate of ISRO and Indian Institute of Remote Sensing. I stayed in that campus. And today, that campus hosts this international center for space science technology education. Last 25 years, this is a silver jubilee. And after 10 minutes, 15 minutes, I have governing board meeting of this particular center based in Dehradun with chairman of ISRO chairing the meeting, and I'm the observer from United Nations and will be chairing the meeting. Someone open the microphone and is noisy.
Doctor?
Hello. Yes, please. Is there any question or anything?
Dr. Andre?
Yes, sir. Hello?
I,
Hello?
you are audible, sir.
Yeah, okay, okay.
Okay, shall I continue?
Yes,
Hello?
sir.
Okay, can you mute the microphone because it's very noisy? Others should close. Okay. I don't know why people are keeping microphone
Hello.
not muted. Okay, thank you. Okay, I'm concluding in 5 minutes. If there is any question, I will take for 5 minutes and then we'll call up this lecture. So you can go to this campus and you can take the training on satellite remote sensing, satellite communication, satellite navigation, satellite meteorology, and many other programs. You can have it as a 1 week, 2 week, or 1 month courses or postgraduate diploma in satellite remote sensing. So this is what one can do, and these are very good training. And if you have enough manpower trained in your college or university in the areas of space technology, and these are really wonderful remote sensing training program. They are available in Dehradun, and if enough manpower, you can incorporate these into your curriculum so that the students that are coming out, they know the potential of space technology, which I have tried to explain in this short time. And probably it will help in driving your current projects on climate smart agriculture or sustainable agriculture. And it will also give a lot of information, basically, on how to manage and monitor sustainable development. So you can see, we also conducted, you can find report of this conference from my presentation, this link. I have shared this presentation with the organizers, Professor Ravi Andre. He can email my presentation to all of you. You can click on this link and see the report of the conference that I conducted last year on space solutions for sustainable agriculture and precision farming. This year, in 2020, during the lockdown period, I was 5 months, I was in Pune. I came for some other reason and I got stuck in lockdown for 5 months. I worked from home from Pune. And while doing that, there was locust attack around June, I think, May, June. So immediately we organized a global webinar on space-based inputs for locust early warning and preparedness. This entire recording is also available on the YouTube. That demonstrates about 8 experts talking about how you can use space technology for locust early warning and preparedness. So this kind of work you can also access from our websites. I was telling you that we have a program called United Nations Platform for Space-Based Information for Disaster Management and Emergency Response. I coordinate this program globally, and we address important thing here is drought monitoring and flood monitoring, which also matters for agriculture, sustainable agriculture. And you can see in this photograph that we go in many countries offering such kind of programs and strengthening use of space technology in disaster management and also by contributing to agriculture. So this is my last slide. I'm summing up my presentation. What we saw so far, whatever you are doing is not a local work of improving agriculture, but you are contributing to national development as well as achieving a global indicators, that is sustainable development goals. We have seen you are also contributing to sustainable development goal 2, that is no poverty, and also making very high contribution to sustainable development goal 13, that is climate action. Space technology, by integrating it with other technologies, are the wonderful tools for sustainable and climate smart agriculture. Today, there are a lot of sensors. They are Wi-Fi enabled, or they can communicate data to remote location. We call it, nowadays, we call it Internet of Things. Those can be placed in the field or on the equipments. You have satellite images. You can have applications like artificial intelligence. You don't need a lot of manual inputs today. You can train the systems and understand the data. Then most of the satellite images are nowadays a big data, and it is available as a crowdsourced platform. So you don't need big servers and machines today. Our entire Google Images cloud, you can see today. All Copernicus images of European Space Agency are open source data today. India's Bhuvan is a platform by ISRO, Indian Space Research Organization, is also cloud data. So you can access a lot of data today free of cost, and you can derive these kind of maps and geointelligence, which can be useful for sustainable and smart agriculture. And this is where I am leaving my lecture with very, very important note that world is entering into fourth industrial revolution. What is fourth industrial revolution? You can go to the website of World Economic Forum, WEF, and see. Basically, first industrial revolution was more about mechanical industries. Second was more about electrical, when electricity came into force. And third was about electronics, computers. And now we call it fourth industrial revolution. New era has begun. Just a minute. हाँ व्हाट्सअप. हाँ 5 मिनट में मैं दूसरा लेक्चर दे रहा हूँ. आई एम फिनिशिंग इन 3 minutes and then I'll joining your minute. Okay, bye. See you. Bye. Sorry, this was a call from ISRO, our governing board meeting. So I had to leave in 5 minutes. Fourth industrial revolution is basically bringing together all the technologies, artificial intelligence, open source technologies, Internet of Things, blockchain technologies, all these technologies coming together and offering you new joint technology that would even function as good as a human mind. This is the era of fourth industrial revolution. So now you will see warehouses, agriculture warehouses. Soon they will become smart warehouses. Sitting anywhere, you will understand which warehouses have what kind of thing and all kind of things. So a lot of changes are going to happen in next 4 to 5 years with fourth industrial revolution, with 5G and all coming in. And we should embrace these technologies for promoting smart and sustainable agriculture using earth resources sustainably, judiciously, so that prosperity comes to us not for short term, but it comes us for long term. Those who are Marathi can go back to my slide. There is a poem called Tahan, which means thirst, pass. You can read that. That is on my own village, and you can understand that climate smart agriculture is something I have faced it myself also. Although we talk of all technologies globally, but at local level, challenges are very, very high. And we can really use technologies in a way to handle it, because locally people don't understand it, or they can't envision those kind of things. So with this, I would like to conclude that although we are contributing globally, we have to act locally. So sustainable development goal is a global, but doubling farmers' income is a local. And what you are doing through smart climate agriculture is acting locally to contribute globally. Thank you. You can email me if you wish. You can use my email address to ask any question or any discussion or comment or criticism. You are all welcome. I would like to thank Professor Ravi Anle and his team and Vice Chancellor of the university. This is my own university. I'm product of the same university. So it's my pleasure to be associated with university for this particular course. Over to coordinator to conclude this,
Yes.
because in 5 minutes I have to be back in another
Yes,
meeting now.
yes, sir.
Thank you.
Thank you very much, sir, for your very informative lecture on overview of international efforts and contribution of space technologies. Also highlighting some very informative topics such as sustainable development goals, doubling farmers' income, IoTs in agriculture. Also, you have highlighted the UN Spider program. So thank you very much, sir. On behalf of CAST CSAWM project, I express my sincere thanks to you, and all on behalf of all the participants. Thank you for giving us a very valuable time and informative session. Thank you, Shirish sir.
Thank you and have a wonderful day. Bye.
Thank you.